Hi, this is Gabriel Callsen. I'm responsible for ICMA's work on fintech and market electronification, and I will give an update on the workshops we had recently with ISDA and Regnosis on the common domain model for repos and bonds. I'm delighted that Labeis from Regnosis has joined us today for this recording. Perhaps Leo, you can say a few words and introduce yourself.
Hi everyone, and thanks Gabriel for extending the invitation. So I'm Leo Labeis. I'm the CEO and founder of Regnosis. We've been assisting ISDA in the development of the common domain model, initially for derivatives, but more recently, as we're going to present, extending to other markets like securities.
Thanks, Leo. So following the meeting of the ERCC, the European Repo and Collateral Council in November 2019, it was agreed to explore the development of ISDA's common domain model for repos and bonds. And in the last 3 months, we have worked together with ISDA and Regnosis and organized a series of workshops. And the focus of these workshops was to model in the CDM certain features of open repos, repo interest payments, and the transfer of cash and collateral of both legs, so modeling a simple DVP scenario. And the aim of these workshops was really to demonstrate the practical benefits of a consistent data model, which is machine readable and involving all participants, so choosing a hands-on format, and importantly, also give a real-time demo of what the CDM does, how it works, and what the outcome is. So if we go back a step, just to recap what the ISDA common domain model is, Leo, how would you describe the CDM in simple terms?
The ISDA CDM is a standardized representation of trade and events that occur throughout the life cycle. So typically, if you look at the left-hand side of the slide that you see on the left, this represents the way the market operates today, featuring a few market participants like a bank or broker-dealer, a client, which may be from the buy side, potentially involving a trading venue like an exchange. And throughout the transaction life cycle, you're going to have a number of events. Some of them are representing on the slide, like new trade, increase, reset. You also have cash flow payments and so on. And basically what the yellow and the green pictures represent is the fact that everyone implements those trade events, even though operationally you're meant to be doing the same thing. Everyone implements them in a slightly different way as part of their technology implementation. So the consequence of that is obviously operational inefficiencies, pervasive reconciliation issues that are everywhere. And the common domain model aims at addressing that issue and effectively provide a platform that enhances interoperability and reduce reconciliation issues, as well as promoting straight-through processing through the market. So in the common domain model, which is effectively modeling all those trade events, but represents them as a distributable, executable code, all those life cycle events, new trade, increase, reset, and so on, including cash flow payments, are represented in exactly the same way. And the state transition is fully specified by the CDM, which means that whether it's the bank, the client, the trading venue, everyone will represent those events in the same way, which virtually eliminates reconciliation issues and also provides a platform onto which the industry and their solution providers can provide a straight-through processing solution.
I see. So to recap, it is a standardized digital model for trade processing to standardize how the entire life cycle from A to Z is represented in the various IT systems, whether it's between market infrastructures, venues, order execution management systems, CSD, CCPs, and trade repositories. And it can be used for a wide range of functions, whether it's for quoting, trade execution, trade confirmation, reconciliations, settlement, risk management, or regulatory reporting. And I also understand that it is a common foundation for, well, as such, for developing innovative solutions, whether it's distributed ledgers, cloud, but also conventional technologies, just starting off from a common, consistent digital representation.
Yes, that's exactly right.
One of the questions that came up in the workshops was the relationship between the CDM and existing data standards and messaging protocols. For example, FIX, which is widely adopted in fixed income secondary markets in particular, and is being developed for repo, FPML, which is the standard for derivatives, but also other formats such as ISO 20022 or extensible markup languages, connections to APIs. How would you describe the CDM in terms of how it interacts with those standards?
Yes, this is a very good representation of what the CDM is. And in fact, I often like, when asked about what it is, to start by what it is not. And that's the last thing that the industry needs right now, as is apparent from your slide, is yet another standard. The industry is replete with those right now. There are many, be it the ones used in front office and execution, or the one used for regulatory reporting. So the CDM did not purport to provide yet another messaging standard that would try and replace the existing ones. Rather, what the CDM provides is effectively a common language by which those standards interoperate. So a typical front-to-back workflow that illustrates that point is the sort of end-to-end from when a trade gets executed to when it gets confirmed, and then when it gets reported. And throughout that end-to-end, it will probably use a variety of messages from potentially FIX on the pre-trade and execution to FPML if it's in derivatives as a support for confirmation, to ISO 20022 for reporting to the European trade repositories. And what is critical to enable straight-through processing throughout that front-to-back flow is the ability for those different existing messaging standards to interoperate. And effectively, the CDM provides a common language to facilitate that. So rather than a new standards, it's really the language that allows those existing standards to interoperate. The reason why, and that gets me to the second point, which is the fact that the CDM is not a solution and should not be a solution. And it is fundamental that it remains an enabler of solutions. And the reason why it's possible to do so is because the CDM is, by providing a language and effectively allowing those standards or those solutions to talk to each other, is fundamentally what it provides, in addition to what messaging formats provide, is the ability to handle very expressive logic, which then gets translated, as we said earlier, into executable code. And it's that logic that allows those existing messaging standards to interoperate, because we can effectively code the logic of their mapping. By the same token, this is how we enable interoperability of solutions, by effectively providing a library of functions and executable code that every technology implementer can then reuse directly as part of their implementation, rather than starting from scratch. Now, why is it really important that the CDM in and of itself is not a solution and is only enabler of solution and stays at that level? Well, that is because the industry, again, is replete with solutions, technology providers providing efficiency to all the part of the front to back flow that we discussed. The problem is that those solutions provide both the point solution that addresses that part of the workflow, as well as the standard and the data model by which every market participant has to connect to effectively use that solution. And because everyone provides a different one, then that's where the interoperability issue comes up. So it is extremely important that the CDM remains at the level of just providing the platform for those solutions to talk to each other. It's really an enabler for technology providers to bring solutions quicker to market, because it means they don't have to go through the process of re-engineering, reinventing yet another data model that is very specific to their solution, but that would only operate in a silo that accelerates them while providing interoperability to the end users.
So just to recap, the CDM as such doesn't replace any existing standards, but it is essentially a connection or an interface between different standards and messaging protocols.
Yes.
So in the workshops that we have held, in very practical terms, we have followed a number of steps to understand how the CDM can be used and what the benefits are, looking at the commonalities between derivatives and repos, but also identifying the gaps that exist between certain processes in derivatives and repos. And from that, then drawing conclusion for the further development of the CDM. So from a very practical perspective, the CDM, or common domain model, maps out all existing processes within the derivatives world, decomposing or breaking down how transactions are presented. And we have adopted a similar approach in the workshops with participants of the workshop. And in practical terms, that meant describing the structure and operation of an open repo and specific features such as the repo rate, a re-rate event, termination, but then also a simple DVP scenario, which involves the transfer of cash and securities of both repo legs, then outlining the sequence of the steps, for example, in the payment of repo interest, also the differences to coupon payments or manufactured coupon payments in repo transactions, and the transfer of cash and collateral between the parties. So then, based on the discussions held in the workshop, we identified a number of commonalities between derivatives and repos. So looking at the table, from the left to the right, we have CDM lifecycle components and CDM terminology. Then we have a section for derivatives and the corresponding features, then those for repos and gaps that were identified in the workshops. So if you look at how the different components of a derivatives lifecycle are broken down in the CDM, we identified a number of primitive events or building blocks that are already in the CDM and that can be used for repos. For example, cash transfer and security transfer events, which in the CDM are used to model interest payments in a derivative transaction. And this can equally be applied for a DVP scenario in a repo. However, one of the gaps that we identified was that at this stage, the common domain model does not cover securities-related cash flows. So for example, the issuance of an instrument, the coupon payments that occur, and the redemption. Then we also looked at specific features of open repos, given that there is common ground between open repos and certain components in swaps. For example, we looked at what is in the CDM referred to as an exercise event, so the exercise of an option, which is conceptually similar to the ability to terminate a repo. In the CDM, this is also referred to as cancelable provision for a call option in a swap. So there are certain, I think, similarities, but we also noted that there are differences, different processes, and also a different underlying logic. For example, terminating a repo means terminating the same contract, whereas in a swaption, it means entering into a new contract. A call option in a derivative has an expiry date, potentially can only be exercised on certain dates or certain points in time. Perhaps you could further elaborate on the current state of the CDM in representing terms and price change.
Yes, so that's exactly right, and this illustrates perfectly the fact that even though the ISDA CDM originally started with the use case of covering derivative, it was very important from the start, as part of the work that we had been doing, that the model was constructed in a way that could be easily extended or just simply work also out of the box for other asset classes. And the reason is very simple. It's because the membership that stands behind the various trade organizations, behind those various markets, are essentially the same members. So for them, it's very important not to, in the end, have yet another set of solutions that would operate in silos. So in that respect, in the same way as you can think of products, be it derivatives or repos, be constructed by assembling economic components, the same idea has been implemented for the event model in the CDM, which is rather than in hard code the fact that a partial termination or a novation or a clearing event or an interest payment is going to be defined exactly as such in the model. Rather, those business events are being constructed out of building blocks, which are called primitive events. So a very good illustration that you presented is the fact that interest payment on an interest rate swap consists of essentially cash transfer between the parties, and that those transfers are exactly the same primitive event that can be used for a DVP scenario of a cash leg and a security leg of a repo. And we went through one workshop that specifically illustrated that point. So effectively, we need to, there is more work to do to construct the set of business events that are really applicable to repo, but the building blocks in the CDM are already there to do that. There is one potential exception, which is on your slide, which is collateral substitution, which is not something that has been looked at so far, but is definitely something that should be extensible in the CDM. So we were very pleased to put that, say, extensibility design principle to the test, so to speak, by working with you on trying that out and seeing a positive outcome. So I would say probably 3/4 of what we need is kind of already there.
Yes, and I think one very obvious gap is, of course, the reference to the documentation, where the CDM refers to ISDA documentation, for example, to master agreements, credit support annexes. And in the case of repos, what we would have to incorporate going forward is a reference to the GIMRA, for example, to define repos, employ the correct terminology, but also some of the concepts that were discussed in the workshop, for example, the meaning of contract, variation in terms of a contract, etc.
Yes, absolutely. And for that, it's obviously this is not the type of thing that we can work on in the abstract. And we are very pleased to have the opportunity to work with your membership and the subject matter experts to effectively, do that extension of the common domain model in the right way. So the infrastructure is there to be able to do that, but it's a matter of putting those very tangible use cases on the table and working with your subject matter experts to actually develop and deliver it.
So in terms of next steps, following the workshops that we have held, we agreed that we will now create a roadmap for the development of the CDM for repos and conduct a comprehensive gap analysis between, on the one hand, the existing components in the CDM that can be reused for modeling repos and bonds by extension, and the components that will have to be newly developed. For example, as just mentioned, collateral substitution. But we will also take into account relevant components in FPML for repos, as well as other relevant standards, whether it's FIX or ISO 20022, etc. And what's going to be important going forward to undertake this gap analysis, but also outline what is required in terms of time and resources to develop it, is data samples or data schemas to understand how the data is represented in member firms' different systems. So any firms who are willing to commit time and resources to this project are very welcome to reach out to us. I don't know if you wanted to add to it, Leo, or?
We take a very pragmatic approach to the implementation of the CDM. So I would reiterate Gabriel's call that rather than working in the abstract on designs and concepts, which we do, but we also need a practical implementation and testing, and that can only be done based on actual data. And this is really a very important part of the approach of the development of the CDM, which is essentially test-driven, which means that every CDM development, implementation, and subsequently released is being extensively tested based on actual data sets, and this so-called integration testing is integral to the release process of the CDM. So working out of the real world is really a development paradigm that we follow very strictly.
So now to conclude, further information is available on our CDM website, where you can find the supporting materials of the workshops, but also background information on the CDM. And again, firms that are interested in developing the CDM are encouraged to get in touch with us. You have our contacts here at the bottom. And in case, if you have any questions or would like to discuss further, then please do get in touch. Leo, thank you very much for joining us, and thank you for listening.